All right, everyone. Hi, thanks for joining this session today. My name is David Frazee, and I'm a product manager on the Azure Network Security, Customer Experience, and Engineering team here at Microsoft. Joining me is my colleague Shabaz Shaik, and today we're going to be talking about the different SKUs we have available for Azure Firewall and their respective feature set. So for the agenda, I'll touch on a quick overview of what the Azure Firewall is, and then I'll talk on our basic and standard SKUs. My colleague Shabaz will then take over and talk about the premium SKU and demonstrate what these different offerings look like within the Azure portal. All right, so let's get started with an overview of what Azure Firewall is. So Azure Firewall is a cloud-native and intelligent network firewall security service that provides the best-of-breed threat protection for your cloud workloads that are running in Azure. It is a fully stateful firewall as a service with built-in high availability and unrestricted cloud scalability. It provides both east-west and north-south traffic inspection, and it also provides outbound SNAT support and inbound DNAT support. Azure Firewall can be configured during deployments to span multiple availability zones for increased availability. And then with availability zones, your availability increases to 99.99% uptime or a 4.9 uptime. With the unrestricted cloud scalability, Azure Firewall can scale out as much as you need to accommodate changing network flows that your environment may see. Additionally, all events are integrated with Azure Monitor, allowing you to archive these logs to a storage account, stream events to an event hub so they can go to a third party or send them to Azure Monitor logs. Let's review some different use cases where you can implement the Azure Firewall in your environment. You can deploy the firewall directly into a virtual network using a traditional hub and spoke method. In this instance, the Azure Firewall lives within a centralized virtual network where all networks with workloads will peer directly with that hub virtual network. This allows for inspection within the same centralized hub between the spoke virtual networks, traffic to the internet, and additionally, traffic to and from an on-premises branch or another cloud provider using a VPN or an express route circuit. You can also deploy the Azure Firewall into a virtual WAN hub, transforming that hub to what we call a secured hub. This provides the same flexibility of inspection from a virtual network deployment, with the outed route management configurations available in virtual WAN. So in this environment, you do not need to manage route tables to force the traffic to the Azure Firewall within these spoke virtual networks, as the hub would do, or how you would do it in a hub and spoke. But when you have a secured hub, these routes will be plumbed into those spoke networks as part of the service. Finally, you can place the Azure Firewall into a forced tunnel mode, where further inspection or internet breakout is handled by another Azure Firewall or via third-party firewall that's deployed on premises or elsewhere, either in the same environment in Azure or another cloud provider as well. All right, so now let's talk about Azure Firewall Basic. So Azure Firewall Basic, it is in preview at the moment, is intended for small and medium-sized or SMB customers to secure their Azure cloud environments. It does provide essential protection that SMB customers may need at an affordable price point. So Azure Firewall Basic is very similar to Azure Firewall Standard, but it does has some of the following limitations. Those are it will only support threat intelligence in alert mode only. It will not allow for alert and deny. It is for the Azure Firewall Basic. This SKU is set to a fixed scale unit of 2 virtual machine backend instances. So different than the standard and premium with the unrestricted cloud scalability. For Azure Firewall Basic, this is scaled or fixed to 2 instances. But it is recommended for environments with a maximum throughput of 500 megabits per second. You can configure NAT rules, network rules, and application rules on the Azure Firewall using either classic rules or firewall policy. Firewall policy is definitely the recommended method moving forward. Azure Firewall denies all traffic by default until rules are manually configured to allow traffic. For NAT rules, inbound internet network traffic to your firewall public IP address is translated and filtered to the private IP addresses on your virtual networks. You can centrally create, allow, or deny network filtering rules by source and destination IP, port, and protocol. Since Azure Firewall is fully stateful, it can distinguish legitimate packets for different types of connections or flows. You can limit outbound HTTP or HTTPS traffic or Azure SQL traffic to a specified list of fully qualified domain names or FQDNs, including wildcards. This feature doesn't require TLS termination. You can associate up to 250 public IPs with your firewall. This enables following scenarios like DNAT and SNAT. For DNAT, you are translating you're translating a standard port to a specific instance in the backend. When you have multiple public IP addresses, you can translate multiple standard port instances to your backend servers. So an example is you have 2 public IP addresses. You can translate TCP port 3389 for both of those IPs. Or typically, you would only be able to do that 1 IP per port. For SNAT, the more ports are available for outbound SNAT connections, reducing the potential for SNAT port exhaustion. So at this time, Azure Firewall randomly selects the source public IP address to use for a connection. If you have any downstream filtering on your network, you need to allow all public IP addresses that are associated with the firewall. Azure Firewall doesn't snap when the destination IP is a private range per RFC 1918. And it is important to monitor snap port utilization through metrics, as snap port exhaustion may cause new connections to not be established intermittently. You can also use NAT Gateway with the Azure Firewall for outbound connectivity to almost double your potential snap ports. Policy Analytics has been developed to help IT teams manage Azure Firewall rules over time. It provides critical insights and recommendations for optimizing Azure Firewall rules with the goal of strengthening your security posture. Policy Analytics helps IT teams address these challenges by providing visibility into traffic flowing through the Azure Firewall. Key capabilities available in the Azure portal for Policy Analytics, they include firewall flow logs, rule analytics, a policy insight panel, and single rule analysis. Okay, so now we'll move on to our next SKU, which is Azure Firewall Standard. Azure Firewall Standard provides the layer 3 to layer 7 filtering and threat intelligence feeds directly from Microsoft Cybersecurity. It includes all capabilities of the basic SKU with the introduction of the unrestricted cloud scalability, as well as the ability to use alert and deny mode for threat intelligence. And so we'll talk about that a little bit more. Threat intelligence-based filtering can be enabled for your firewall to alert and deny to and from known malicious IP addresses, FQDNs, and URLs. The IP addresses, domains, and URLs are sourced from the Microsoft Threat Intelligence feed, which includes multiple sources, including the Microsoft Cybersecurity team. If you've enabled threat intelligence-based filtering, the associated rules are processed before any of the NAT rules, network rules, or application rules. You can choose to just log an alert when a rule is triggered, or you can choose alert and deny, which will explicitly deny that flow. By default, threat intelligence-based filtering is enabled in alert mode. You can define allow lists, so threat intelligence won't filter traffic to specific listed FQDNs, IP ranges, or subnets. And then if you have, let's say you have a large amount of FQDNs or IPs that you actually need to build exceptions for with threat intelligence, you can accomplish this with a batch operation. You can upload a CSV file with the list of IP addresses, ranges, or subnets, and then that will populate for your threat intelligence exceptions. The standard comes with custom DNS support. So by default, Azure Firewall uses Azure DNS for name resolution. The DNS server setting lets you configure your own DNS servers for Azure Firewall name resolution. So you can configure a single server or multiple servers. And if you configure multiple DNS servers, the server used is chosen randomly. So you can configure a maximum of 15 DNS servers when using custom DNS. And Azure Firewall can only resolve names using Azure Firewall can also resolve names using Azure Private DNS zones. So the virtual network where the Azure Firewall resides, it must be linked to that Azure Private DNS zone. And then the Azure Firewall will be able to resolve these private DNS zones. This is useful for private endpoints or If you just have an internal domain for your environment, the firewall will be able to resolve this, either using the DNS zone or if you have this custom DNS server solution as well. You can configure Azure Firewall to act as a DNS proxy. And so a DNS proxy is an intermediary for DNS requests from the client virtual machines to that DNS server. If you want to enable FQDN filtering and network rules, then you must enable DNS proxy and update the virtual machine configurations to use the firewall as a DNS proxy. This can be done by changing the DNS setting on the virtual network to use the private IP of the Azure Firewall. If you enable FQDN filtering and network rules and you don't configure the client virtual machines to use the firewall as a DNS proxy, then DNS requests from these clients might travel to a DNS server at a different time or return a different response compared to that of the firewall. It's recommended to configure client virtual machines to use the Azure Firewall as their DNS proxy. This puts Azure Firewall in the path of the client request to avoid inconsistencies within flows. When Azure Firewall is a DNS proxy, there are two caching function types. One is the positive cache. DNS resolution. When DNS resolution is successful, the firewall will cache these responses according to the time to live value, up to a maximum of 1 hour. For a negative cache, if the DNS resolution resulted in a no response or no resolution, the firewall will cache these responses according to the time to live, up to a maximum of 30 minutes. The DNS proxy stores all resolved IP addresses from FQDNs and network rules. And so as a best practice, use FQDNs that resolve to one IP address if possible. So next is web categories. So web categories let administrators allow or deny user access to websites such as gambling, social media websites, and others. The categories are organized based on severity under liability, high bandwidth, business use, productivity loss, general surfing, and uncategorized. It's possible to create a category exception by creating a separate allow or deny rule collection with a higher priority within the rule collection group. And an example of that is having, as you can see here in the slide, we do allow LinkedIn with a higher priority, but we deny the rest of social networking. So typically LinkedIn would be put into the social networking web category. So that deny social media would typically block LinkedIn, but we override that with a higher priority rule. For web categories, there is a category search. So you can identify what a category is, or what category a given FQDN or URL is by using the web category check feature. To use this, select the web categories tab under firewall policy settings. This is useful when defining your application rules for destination traffic, and you want to use web categories as the destination value. Okay, and with that, I am going to pass this over to Shabaz.
Thank you, David. Give me a moment. I'm sharing my screen.
Mm-hmm.
Please give a thumbs up if you're able to see my screen.
Yeah, all good.
All right. Hello, everyone. This is Shabaz. I'm a product manager in the Azure Network Security Customer Experience Engineering team here at Microsoft. I will be taking over and talking about Azure Firewall Premium, which is the last SKU of Azure Firewall. When we look at Azure Firewall Premium, the major features that we come across are the advanced threat protection features like TLS inspection, intrusion detection prevention system, URL filtering, and web categories. This is on top of all the previous features we discussed about in Firewall Standard and Firewall Basic. So basically, it will have all the features we talked about before on top of that, these threat protection features. So now let's talk about each of these features separately. So the first feature we are looking at here is the TLS inspection feature. So basically, when we have HTTPS traffic traversing the firewall, it is in an encrypted format, and for the firewall, it will be really not possible to see what is inside this traffic. So it becomes really important to decrypt this traffic, and that's where TLS inspection comes in. So with the help of this TLS inspection feature, the firewall forms a tunnel between the client and the server separately. And instead of presenting the server certificate, the firewall presents its own certificate to the client so that the client can verify and trust this certificate as long as the root certificate is installed at the client level. So with this particular process, what we are trying to do is we are intercepting the encrypted traffic. We are looking into it and inspecting this traffic and then re-encrypting this traffic and forwarding it to the destination. Thereby, we are making sure that all of this traffic is properly inspected. And from the security standpoint, it will be a great feature. And the next feature we have is the intrusion detection and prevention system. Any traffic that passes through the firewall will be inspected by this IDPS feature basing upon signatures that we have. So this is a signature-based feature where it will look for some anomalies, sequences, and any malicious activity patterns that could cause any threat to the resources that we have in our environment. So with this feature, we can inspect this traffic, and if there is a match with any of the signatures we have, we can get alerted for that particular traffic. Also, we can try to deny it optionally when we want to do so. We currently have like over 58,000 rules spanning over 50 categories like phishing, botnets, and more. So all of these signature IDs are regularly updated, and we don't have to manually make changes to that. If at all, in case we want to manually disable a signature, we can do that as well. And we can also add a bypass list for this IDPS system to bypass a certain flow of traffic. Moving on, the next feature we have is the URL filtering feature. So this is basically an extension to the Azure Firewall's FQDN filtering capability. So, instead of just looking at the FQDN level, now with URL filtering, we can go deeper and look at more granularly. For example, previously with FQDN, we can only filter up to the level of let's say contoso.com. But with this URL filtering, we can look at the complete URL like contoso.com web videos as we see in this particular slide. So thereby we have granular ability to filter the traffic as per our needs. Moving on, the final feature that I wanted to talk about is the web categories feature. So web categories feature, we have already discussed about this in the standard SKU, but this is a step up from the standard SKU in the premium SKU that, for example, if someone is going to bing.com/news, in the standard SKU, it will only get categorized as a search engine, whereas we have like URL level visibility in premium SKU. Now, since it is /news, it will categorize it as news instead of search engine. So that's like we have more specific analysis on the traffic, and thereby we can configure our rules that way. All right, so those were the features we had in Azure Firewall Premium on top of the previous features. So this is a slide which is basically giving you an overview of all the features that are present in all the 3 SKUs we discussed, and the basic differences between them. So when you look at the first 2 sections, layer 3 to layer 7 filtering and reliability and performance, basically there's not a lot of difference between basic, standard, and premium, except a few differences like in the basic firewall, you can't have FQDN filtering in the network rules. That's because you do not have DNS proxy and custom DNS supported there in this SKU. And apart from that, the difference there is the cloud scalability part, where the throughput for Firewall Basic is only 500 megabits per second, like David mentioned. And for Firewall Standard, the throughput can handle up to we can handle the throughput of 30 Gbps. And for premium, it is 100 Gbps. So that's the major difference here. And when we move on to the next section, the enterprise integration and ease of management. In the ease of management, all of the three SKUs are almost similar. But in the enterprise integration, we do not have web content filtering, that is the web categories, and DNS proxy custom DNS in the basic SKU. But for the standard and premium, we do have those features. The major difference comes between the premium and the standard is in the last section, which is the advanced threat protection section, where, as we can see in the basic SKU, we only have the alert mode available for threat intelligence based filtering, whereas in standard and premium, we have full capability of alerting and denying the threat intelligence based filtering traffic. The remaining features, if we look at it, they are TLS inspection and IDPS and URL filtering. These three features are only available in the Firewall Premium. So this is like giving you a comprehensive understanding of all the features we discussed so far and how these three SKUs are different from each other. So let's move on and look at the portal directly, how these three SKUs look and how we configure a firewall. So this is the Azure portal. When we go to creating a resource and search for a firewall, you can directly create a firewall by going to this particular section and click on create. The things that will ask while creating the firewall is whether what subscription it's going to be in, what is the resource group, name and region for the firewall, and whether we are going to have availability zone and all of those details. But the one that I wanted to highlight was the firewall SKU. At the time of deployment itself, you can see basic, standard, and premium. You can select any SKU that you want at the time of deployment. And let's say you have selected that, and the next section would be firewall policy. So you can attach a firewall policy to this firewall. If at all you have an existing policy, you can attach it, or else you can create a new policy. And even the policy tier also gets, we get it in 3 different tiers, which is basic, standard, premium, and those policies can be attached to the respective firewall tier. And that's about it. Within we just have to provide the subnet, public IP, and other configuration here, and we will be able to create a firewall pretty quickly within a matter of minutes. So once the firewall is deployed, it'll look like this. When we go to the overview section, we will see all these details, the resource group, location, subscription, virtual network, firewall policy, which SKU it is. Right now we can see that this is a premium SKU, and the subnet, public IP, and all that. We also see the details about which firewall policy is currently attached to it. We also see the details of the rules, network rules, application rules that are currently configured. And we see the details of these advanced threat protection features like threat intelligence, TLS inspection, and IDPS at the overview level itself. If we want to configure all of these rules and these features, we need to go to the firewall policy directly and change those parameters there. So if we go to a firewall policy, this is how a firewall policy will look like. So I have opened up 3 different firewall policies, which are like basic, standard, and premium. I just wanted to showcase the differences between these 3 firewall policies and how they differ from each other. So if we look at the left side of this portal, we see that this is a firewall policy resource. And in the settings section here, we have the parent policy, rule collections, network rules, application rules, DNS threat intelligence, and everything. So if we go to the overview part of it, I just want to showcase, like at the overview section itself, it will tell you which tier it belongs to. It's the basic tier. And like we discussed, TLS inspection is currently not supported in this tier. And similarly, in the IDPS mode is also not supported, since this is only supported in premium. You can see the same thing in the standard policy. It's currently not supported. Whereas in a premium policy, you will see the details of those features. We can see that TLS inspection is enabled here. IDPS mode is currently set to deny. Moving back to basic policy, I want to cover the differences in the network rules. So for example, if we look at the network rules section, we can configure a network rule basing upon source, destination, protocol, action, and everything. However, the destinations that we can choose here can be IP addresses, IP groups, and that's about it. We can't use FQDN in the network rules of Azure Firewall Basic because we cannot have custom DNS here. But whereas in the case of standard and premium, if we look at the network rules section, so here we can see that the destinations are IP addresses. These are the IP groups, and we also have configured FQDN here in the network rules because the standard and premium, they support custom DNS. So that's the major difference in the network rules side of things. Going back to the firewall basic and looking at the application rules. In the application rules section, we can have FQDN as well as FQDN tags as the destination. But we can't have web categories here. And that's the difference where what we see in the application rules section of a standard firewall policy. When we look here, see we have FQDN tags, but we also have web categories available here. So that's one extra destination item that we can configure in the standard firewall. But if we go to the premium firewall policy and look at the application rules, on top of the web categories, on top of the FQDN and FQDN tags, we also have URLs configured as destination. So that's one more thing that we have here in the firewall premium. So you have like a few differences in the firewall policies, how you can configure them. And that's what I'm trying to highlight here. And going back to the firewall basic and looking at the major features like the DNS, if I click on it, custom DNS, so DNS is only available for premium and standard policies. We can clearly see that. But whereas in the case of standard and a premium firewall, we have this option of enabling it and enabling the DNS proxy as well. Same will be with the premium firewall as well. And when we look at the threat intelligence section, like we mentioned before, for the basic firewall, only the alert only mode is available. The alert and deny is grayed out here. Whereas in the case of firewall standard and premium, we have both alert and deny, and it is currently configured as alert and deny. Similarly for the premium firewall as well. So as we can see, alert and deny is here. And going back to the basic firewall, TLS inspection is not supported. We can clearly see that here, and IDPS is also not supported. We can see that here as well. And to the standard firewall, same thing. TLS inspection is not available. IDPS is also not available. But when we go to the premium firewall, we can clearly see the differences. In the TLS inspection section, we are seeing an option to enable this feature here. We can globally enable this at the policy level, or else we can also enable this feature, on top of, at the rule level as well. And for TLS inspection, we need a certificate. We can point to a certificate that is stored in the key vault as well. And when we look at the IDPS section, in the IDPS section, we have like 3 options. We can disable it. We can put it in alert mode, which is your intrusion detection mode, and alert and deny, which is your intrusion detection prevention mode. When we look at the second tab here, these are the signatures that are present. Currently, as we can see, there are around 68,565 rules that are present. And all of these signatures are applied depending upon the directions. Some of these signatures are valid for all directions, like inbound, outbound, internal, and all that. But some signatures are only specific to outbound or inbound. So how the firewall determines that is by using private IP ranges. So if we specify any IP range in the private IP ranges, it will consider it as internal traffic, and only internal rules will be applied for that. So that's why we have this option here. By default, we have RFC 1918 IPs selected here, but we can add more IPs like this to this. And there is a bypass list where we can add source, destination, and protocol. here in this bypass list that will make sure that this particular IDPS engine is not it is not enforced on this flow. So these are the major differences between these three SKUs that I wanted to showcase. And then going back to a firewall directly, I wanted to also show how the logging of the firewall works. So if I go to the logs section of the firewall, I have a few queries that I have set up already. So we can query for Azure Firewall network rule, application rule, DNS query. There are many other filters available. With the help of these new resource specific logs, we now have specific tables for all of these category rules. So let me just select this first line here and try to run this particular query. When I run this query for maybe last 24 hours, let's see what we have. It'll take a minute or two to populate the data. As we can see, we are getting all the logs for the network rule that are passing through the firewall. Here in these logs, there are as many details as a security analyst would want while investigating a particular flow. You have protocol details, source IP, source port, destination IP, destination port, and the action policy that was enforced, rule collection group, rule collection. Everything is here inside this particular log. And we can also see more details by just expanding that log item. And if we want to get more granular in our querying, we can add more parameters here. Like I just want to see the network rule logs which only has deny as action. So I'm running that. And you'll get that particular result. So action, as we can see, only deny we are getting in the results. So similarly, if I move this to another time frame, we can get all those, and we can also be as specific as we want by selecting more parameters. Like I've selected source IP, destination IP, action. You can select more which are available in the columns here. So I'm just running this whole query. And if I run this, we will get like an output which is much more smaller because we just have few logs here with this particular parameters matching. So therefore, we have like a clear way of filtering for these logs and looking at them in a detailed fashion. And similarly, we looked at the network rule. We also can look at other rules like the application rules, and those logs will also have more details on the different types of traffic patterns we had, the FQDNs and everything, destinations, and all of these is listed here. And we also can see DNS query logs, and finally we can also see the IDPS signature logs as well. So this IDPS signature logs will give you more details on what signature was matched and what was the action. So as we can see, we had an alert action, and if we just go into the details, it will tell us what is the description of this particular match, and what is the resource ID, and all of those details will be present here. So this way we can get as much information about the traffic that is passing through the firewall, and it will be really helpful in any sort of investigation that we'll be doing. And that's about it. That is the end of the presentation. I just want to go ahead and give some time for the questions, if at all you have any questions here.
Great, thank you, Shabaz. So we do have quite a few questions. The first one is, how is threat intelligence in Azure Firewall different from Microsoft Threat Intelligence? I mean, if I enable threat intelligence in Azure Firewall, then don't I need to enable the same on Sentinel?
You don't need to, you only need to enable threat intelligence on the firewall if you're talking about network traffic. Sentinel is a different category there, but it all based on reputation-based, IP reputation-based feeds that we have, and also domain reputation. So depending upon that, we have a blacklist and whitelist that will help us determine if it's a malicious source IP or not.
Great, thank you. The next question we have is, how prevalent is the use of TLS inspection for modern environments, as many services no longer allow man-in-the-middle decryption?
I would say it's still prevalent. It depends on what services we are talking about. Some of the financial organizations might not want to like it, but it's up to them because it's a security risk if they're not inspecting that traffic.
Great, thank you. The next question we have is, can we define our own web categories, or can we only use the predefined ones from Microsoft?
Right now, we can use the predefined ones in Microsoft, and probably they have covered everything. But if at all you have a concern related to that, you can always open a support case and talk to the support Azure Firewall support. And if there is any miscategorization, you can also get help from that.
Great, thank you. The next question we have is, currently we are using Azure Network Gateway as a hub. Is there a way to move to Azure Firewall replacing Azure Network Gateway?
For internet traffic, you can use Azure Firewall for outbound and inbound, but I would like to know more about the scenarios. But for now, I can answer just that.
Great, thank you. The next question is it possible to filter based on application signature?
Currently, we only support three application support, which is HTTP, HTTPS, and SQL. But we do have a plan for application ID as well.
Great, thank you. The next question we have is, can firewall policies be maintained in IAC, like Azure Bicep or ARM?
I think they can be maintained unless, David, do you have any input there?
Yeah, they can absolutely be maintained using Bicep, ARM templates, Terraform, PowerShell CLI, whichever form you'd like to use for that.
Great, thank you. The next question we have is, can this replace the typical UTM boxes available on Azure?
UTM boxes, as in need more details there. I don't understand the question, but if we are talking about the regular on-prem firewall, definitely we can replace the on-prem firewall with the help of Azure Firewall.
Great, yeah, while we're waiting for more clarity, we'll go to the next question. Since Azure Firewall mainly does outbound filtering, is it possible to get inbound HTTPS traffic via web app firewall and have the outbound traffic via firewall? Can you give any guide for this?
Yes, there are different scenarios that are currently supported. Azure Firewall supports both inbound and outbound traffic, enforcing policy enforcing. But in the case of TLS inspection, it will support outbound. But if we want inbound TLS inspection, we have to use it alongside of App Gateway. And there are scenarios available in our Azure documentation, which will clearly guide you for that, like how to use App Gateway and Firewall together.
Great. The next question is, in case of any issue on recent configuration, is there any option to auto revert back to previous configuration with a predefined set threshold time?
That feature is currently not there, but we are working on it.
Okay. Let's see here. The next question we have. Oh, sorry.
Yeah, just want to add to the previous question. We also have separate solution for backing up Azure Firewall policy. We have a logic app for that and a blog as well in our tech community. We can make use of that particular solution to take regular backups of the policy. And then we can restore that backup whenever we have an issue with the currently configured policy. But there is no in-house, like within Azure Firewall solution for that, but you can use the logic app that we have created.
Great. The next question is, does Microsoft have a recommended firewall and/or security solution designed for SaaS services like Power Apps connecting over MS Backbone into Azure Cloud PaaS data sources such as SQL DB?
I do not think of any particular ones, but would need more clarity on this question and the scenario as well. So would be something, if they can submit this question on the forms that we have, then we can follow up on this.
Great. The next question is it only possible to activate deny action for the whole threat intelligence, or can one define groups for alert and deny?
We can have both alert and deny, but if it's a basic firewall, we only have alert there. But for standard and premium, we support alert and deny.
Great. The next question we have is, can we use Azure Firewall in conjunction with Front Door?
Yes, definitely we can use it. Front Door can have a backend as public IP, so we can have firewalls public IP as the backend.
Great. And can the Microsoft Firewall be used in conjunction with other third-party firewalls?
Yes, definitely we can use it. That's why we have the force tunneling mode in Azure Firewall, where they can redirect the traffic to another NBA or on-prem firewall depending upon their needs. So they can work in conjunction with another firewall.
Great. And we did have some elaboration from the person who asked about UTM boxes. They said we have checkpoint/SOFO/PA available on Azure, where we can protect the workloads running on Azure along with IPS, IDS, and content filtering policies. Can this replace those devices?
Yes, it can definitely replace those devices. And on top of that, it will also give you the flexibility of auto scalability and, automatic updates and all that, which those NVAs cannot do. So with Azure Firewall, there is an added advantage there.
Great. The next question we have is, would we be able to configure site-to-site VPN tunnels to other virtual or on-prem firewalls with this?
Yeah, we can have, virtual WAN setup. We can use that. We can also use express route setup. It depends on the architecture we're planning to have. So depending upon that, we can configure it, but we can't set up a direct tunnel to the firewall.
Great. The next question is, can you please explain how Azure Firewall can replace the firewall deployed in data center?
So firewall deployed in data center, I take it as on-prem firewall. So on-prem firewalls, they protect the workloads that are present in the data center. But if at all, you want to use Azure Firewall for protecting your on-prem workloads, at that point of time, we need to have some sort of public IP present in the Azure environment, which has a backend as that on-prem firewall. So in that scenario, we can use Azure Firewall to protect it, but without having any public exposure in the Azure environment itself, we can't protect it.
Great. And is split tunnel configuration supported?
Split tunnel, as in we not exactly split tunnel, but we have the force tunneling mode available, which will direct the internet traffic to another firewall. Split tunneling is basically if you have a VPN connectivity and then sending the internet traffic directly. So that's not there, but there is an option to send the internet traffic to another firewall.
Well, but Shabaz, let me add to that. So we can, though, if we can put the Azure Firewall into a force tunneling mode that forces all traffic to another hop. But if there is a specific public IP on the internet that you want that particular Azure Firewall to be an internet breakout, you can configure it so that it will split that specific flow directly out.
Great.
Okay, thank you for adding that.
Well, that seems to be all the questions we have. So I'd like to thank you, David and Shabaz, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/AzureNetSecFeedback. Thank you and see you next time. Goodbye.